glance down at a smartphone to see some in action. From translation software powered by deep learning, to Smart Reply for your emails, which helps you write emails faster in your personal style, to automated object detection that helps you organize your photos and retrieve your memories quickly. And oh, so much more. It's easy for you to join in the fun as long as you have the data, the algorithms, and the computing power to pull it all off. And to make sure that you do, Google Cloud has your back. We're putting our vast computing resources at your disposal, along with access to data for classic AI applications, so you don't need to go out there and photograph a million cats yourself. And when it comes to algorithms, Google's research teams have designed a powerful suite of tools for you that you can use right out of the box. We've done the math for you so you don't need to worry about it, letting you dive right into everything from classical machine learning methods to state-of-the-art deep learning. Google Cloud is focused on bringing AI capabilities to market as a rich, broad ecosystem to transform your business. From our pre-trained models to our fully managed TensorFlow, we're providing tools so you can harness the power and beauty of your data. We're making it easy for you to create game-changing applications with AI. So how do you get started? The steps required for AI are the same as for machine learning. Think about your task and define success. Prepare your data in the cloud. Build recipes by trying out algorithms until the results look promising. Test your recipe on lots of new data. And then use your solution to transform your business. As you can see, applying AI isn't about arcane math or magical magic. It's practical, and it's a team sport that brings together a diversity of talents to get a project off the ground. No matter what part of the process you're most skilled at, whether you're a business leader, data scientist, statistician, researcher, programmer, or subject matter expert, there's definitely a place for you to put your best skills to work in creating intelligent solutions. And you don't have to do it alone. We at Google Cloud are here to partner with you to give you the resources and teammates you need to succeed. Today, you're going on a journey with us to discover the best of Google Cloud AI. You'll begin by learning how you can infuse AI into your applications with our machine learning services like Cloud Vision. We have sessions on TensorFlow and Machine Learning Engine to show you how you can build custom models. And lastly, we'll dive into guiding you through the ecosystem of ML accelerators, what's out there, and how to navigate the best hardware choices to power your AI strategy. Thanks for your time.
Welcoming everyone from our AI track. So what you just attended was about how managed cloud services make AI possible for everyone. Did you attend that one, Jay?
Yeah, absolutely. So Cassie did a fantastic job and really built on what Oyvind was talking about earlier, right? So Oyvind talked about sort of the things you need, and Cassie's sort of more focused on the questions you need to ask and how you actually approach those individual problems. And I really loved her use of, these are the three things you need to think about. Your information, essentially your recipe, and then the answers that you get. And what I really love is, is the focus on thinking about what answers you want, which actually makes me think about, you really need to understand what question you want to ask.
Correct.
So you can figure out what the answer is, you can figure out what information you need, and then you figure out that recipe in between. Sometimes the answer to that recipe is machine learning or AI, and sometimes it's just simple data analytics. So I think it's really important to understand those questions and what you want to ask in order to understand what you want to get out of it.
So what I also loved was how, she spoke about how AI is built into right on mobile phones. So whenever we look at probably a smart reply option in Gmail, so that does have AI built in where it kind of gives you these automated responses. So these small product features that Google has in terms of, all of our products and services, I think we really have AI in our DNA. What do you say?
Yeah, absolutely right. And we are AI first, and this is very much an AI first event. So actually, maybe we should reintroduce ourselves. Hi, my name is Jay Jenkins. I'm the Customer Engineering Lead for Southeast Asia, and I'm based right here in Singapore, where we're coming to you live.
And hi, everyone. I'm Shaista Alia. I'm the Customer Engineer from India, joining you live from Singapore.
Great. And actually, so going back to Cassie's session, that wine use case was really great because it really simplifies sort of how to think about the problem. And it's easy enough to sort of understand what it is, those two factors, like will I like the wine versus what the age of the wine is. But you can also see how it gets more and more complex as you add thousands of factors, for example, right? What are those lines going to look like, or what are those curves going to look like, or how are we actually going to test whether or not those models are valid? And again, she talks a lot about the approach on how you separate your training data from your validation data and from your test data.
So I think that's really interesting. And I think the next session that we have coming up on the AI track is the crash course on Google Cloud Machine Learning APIs. That's going to be really interesting, because what Google has done for these pre-trained APIs is basically offer you the machine learning that we had within our company, within our products. And you have APIs like the Video Intelligence API, we have the Vision API, we have Translate API, which powers Google Translate application. We have the Vision API, which kind of powers Google Photos. So I think that should be a really interesting session to look out for.
Yeah, and Sarah does a great job talking about those APIs and exactly how you might integrate those, or gives you a vision around how you might integrate those with your products. And we'll also have a special guest customer joining us in that session as well. And again, if I were to link those two sessions together, what Cassie said around being able to understand what answers you want, sometimes those answers come from models that already exist, like the pre-built models and APIs that we have on Google Cloud Platform.
That's correct. And I think just for the folks joining us again, welcome to Cloud on Air. And this is, for those of you who've joined us earlier also, they know what the Cloud on Air is all about. So this is the 4th time we're having Cloud on Air across this region. And this time it's a very unique and special event, since it is global and we have 3 parallel tracks running, and also we have spread it across different time zones to kind of reach out to a wider audience. So yes, that's I think going to be interesting for everyone.
Right. And I know many of you have been with us before in May, July, and October, so definitely welcome back. Thank you so much for joining us. And it's also important to welcome those people that are new, that are joining us for the very first time. And what's also important is that you provide us feedback. So again, that last button on the side will allow you to provide us feedback on the overall event and let us know what sorts of topics you'd like to cover in future events. And also, don't forget, at the end of each session, there's a form where you can actually evaluate each session and let us know what you thought of that session. Was it too high level? Was it too deep? How can we best address your needs in the future?
And also, there's a Q&A button that says Q, and you can go ahead and ask questions which will be answered by Google experts sitting right here in office throughout the event.
Right. I think it's a good point to actually talk about sort of our commitment in the region. So, yes. Earlier you mentioned that we've actually opened up new regions.
That's correct. So we have a data center launched in India, in the Mumbai region, which went live on 1st of November. So it's quite recent. And of course, there's a lot of investment going on in the APAC region. We have also announced something, a new data center coming up in Hong Kong. So we definitely are investing in the region, and because there's a huge market and a huge, call-in for this kind of services.
All right, and we've also launched regions in Singapore and Sydney
correct.
As well. So certainly lots of options for our customers here in the region, so you can place your services in that region and have redundancy within the region as well. Great. So let's talk about industry solutions. So our industry solutions track has just joined us, and they were talking about smarter marketing with Google Cloud.
Yes, and I think just to add on to that, we have the next track coming up for industry solutions is accelerating delivery of healthcare solutions with Google Cloud and AI. Now, Jay, there have been quite a few amazing use cases that I've seen in the healthcare industry all across APAC, be it ANZ or India for that matter. So there have been quite a few use cases, and I think it would be interesting for our audiences to go and watch that session, because that would give them a whole list of use cases and ideas about what Google can do in terms of ML and AI and how we can help the healthcare industry.
Definitely, and actually what I really love about that industry solutions track is it is about how we actually apply AI today
Correct.
Into these verticals. So it's extremely, it allows you to sort of understand how you might use those same sorts of solutions in your industry, even if that is not your particular industry.
Interesting. And also, I think with the session that we just ended, what we need to understand is that AI over a period of, if we go ahead and understand it, okay, I think I'll just break there because we are having our big data track audiences just joining us. So the big data audience just finished up with a session of reimagining data warehouse with Google BigQuery, what's new and what's next. So welcome to the audience joining in from big data track.
Great.
And Jay, do you want to introduce the next track that we have for big data?
Sure. So the next track we have for big data is taking a look at data warehousing with BigQuery. So, there's lots of data that's being collected, and we talked previously about complex analytics and moving those to actionable insights. And sometimes those solutions aren't necessarily around machine learning. Sometimes there's easier ways or ways you can use as a managed service in order to get those actionable insights. And moving your data warehousing to a tool like BigQuery allows you to do that. So enjoy the sessions.
We'll see you right here after the tracks, and don't forget to ask as many questions as you have about the sessions. You have the Q&A button right on your left-hand side, the right to Jay. So yes, we'll see you again.
Hello, and welcome to Cloud on Air, Big Data to AI. I'm presenting a crash course on Google Cloud Machine Learning APIs. My name is Sarah Robinson. I'm a developer advocate on the Google Cloud Platform team, focused on machine learning and big data. You can find me on Twitter at srobtweets. The APIs I'll cover in this presentation fall into two categories. We have APIs to help you make sense of visual content, like images and videos, and we have APIs to help you understand audio and text. I'm going to dive right in by starting with Cloud Vision. Cloud Vision is an API that lets you perform complex image detection with a simple REST API request. Let's take a look at some of the features of Cloud Vision. At its core, the Vision API will tell you, what is this a picture of? You can use label detection to do that. So for this image, I might return elephant, animal, or mammal. Web detection will let you search the web for additional details on your image. So you can find where matching images exist across the web, or where similar images exist. OCR, or optical character recognition, will help you extract text from your images. It can identify the language that that text is in, and it can also tell you where that text is in the image. Logo detection will identify company logos. Landmark detection will tell you if there's a common landmark in the image. Crop hints will help you crop your image to specific dimensions. And explicit content detection will tell you if an image is appropriate or not. We've seen this feature used across a variety of apps that have any sort of user-generated content. Rather than having somebody manually review that content, you can just send it to the Vision API with one REST API request. Next, let's take a look at the JSON response we get back for a couple of these features. First, we'll look at OCR, or optical character recognition. This is a photo I took at the Google New York office, and we can see that OCR was able to extract all the text from this image and also tell us where that text was in the image. The next feature I want to show you is landmark detection. So everyone recognizes this image, right? This is a picture of the Eiffel Tower. It's actually not the Eiffel Tower. This is the Paris Hotel and Casino in Las Vegas. And I wanted to see if Cloud Vision could spot the difference. The answer was, yes, it could. It identified this as the Paris Hotel and Casino. And as you can see in the JSON response, we also get this MID back. And this is an ID that points to this entity in Google's knowledge graph. So if we want to get more information on the Paris Hotel, we can send this ID to the Knowledge Graph API to get more information. We also get a bounding box of where it identified this landmark in the image and the latitude and longitude of the Paris Hotel. The next feature I want to look at is web detection, specifically the entities feature of web detection. And to do that, we're going to use this image of a car. Now, this isn't just any car. This is a car from the Harry Potter movies. I'm a big Harry Potter fan. And this is a car that was used to film the second Harry Potter movie, and it's currently on display in a museum. So passing this image to the Vision API, I wanted to see what entities it was able to return. The first one it found was Art Science Museum, which is a museum in Singapore where this car is currently on display. The second entity it found was Ford Anglia, which is indeed the correct model of this car, and it's even able to tell us that this car is from Harry Potter. Web detection also gives us some other data about the image, which we can take a look at here. It tells us all of the URLs where the same image can be found across the web, and with partial matching images, it's kind of like a reverse image search, so it can tell us where similar images exist across the web. And then finally, pages with matching images will tell us all of the URLs where we can find exact image matches for this image of the car. It's really easy to call the Vision API. It's just a simple REST API, so you can call it in any language you'd like. But we do have a number of client libraries so that you can easily call the API in your favorite language. Here's an example using Node.js. So I create a reference to the Google Cloud Vision module for Node. Then I tell it what types of detection I'd like to run, in this case, face and label. And then I call detect on that Vision object, passing it either the local image URL or a URL that references this image in Google Cloud Storage. Then I'm able to analyze the detection response that I get back. So now you've seen what the Vision API can do. I want to show you some examples of companies using Cloud Vision in production. First company I'd like to talk about is Giphy. And to do that, I'm going to sit down with Nick Hasty, the Director of Engineering at Giphy. Hi, Nick.
Hey, how are you?
Good, how are you?
I'm good.
Thanks for joining us today.
Thanks for having me. It's a pleasure to be here.
Maybe you could start by telling us a little bit about Giphy and what your role is on the team there.
For sure. So Giphy is an animated GIF search engine. Most people are familiar with us through our integrations in places like Facebook and Twitter and Slack or email. We're like the best place to go find that perfect GIF that you want to communicate to someone with and send it through text message or whatever. I've been with Giphy since the very beginning, and I am currently the product lead on the Data and Daggers team. We're kind of like a data-specific R&D team on Giphy that identifies the next thing that we need to be exploring and the next thing that we need to be integrating to make our products better.
So along those lines, I've heard you've been doing some interesting things with machine learning. Maybe you could tell us a little bit more about that.
Yeah, sure thing. So as we've grown over the years, our catalog of GIFs has grown tremendously. So we got tens of millions of GIFs now. I mean, we make our own. We've got UGC. We've got technology that'll take a DVD and turn it to GIFs. We're just kind of swimming in GIFs. Historically, we've had an awesome team of editorial people who were just pop culture wizards who annotate our GIFs and tag them. But that's just not a tenable solution at this point. So I started looking for other ways in which we could add more metadata to our GIFs. There's been crazy advances in machine learning and computer vision lately. But being a startup, it's not necessarily super easy to kind of use these technologies in-house. You have to have like some sort of specialist engineering and have a ton of data to build the models. So when I discovered Google services, I was super impressed by the breadth and the quality of the models. We did some tests, loved what we got back, and so we sent a large quantity of our GIFs through to help supplement our search index.
So you're using it to improve the accuracy of search so people can search for text within
Exactly.
GIFs.
We've already integrated results from the OCR endpoints. So now when people search like GIFs with captions for song lyrics and those kinds of things, they pop up to the top. We're now integrating the web entities, which are like the labels that Google has identified with an image as it is crawled the web. And that tends to be awesome things for us, like celebrities or proper nouns or movies or TV shows. A lot of our content is based in culture and entertainment. So adding that data in to supplement our existing data has helped boosted our search a lot. I mean, we've seen with both services, we've seen independently about a 0.5 rise in CTR after doing A/B tests with the integration. So that's a really big win for us.
Wow, so you're using Cloud Vision to improve search. Are you using any other machine learning tools?
We are. So we're using the natural language processing endpoints as well. So we have added metadata to our GIFs using a tagging system, which has been pretty flat. We wanted to add better titles to our GIFs, but in order to do so, we needed to know a little bit more about our tags themselves. So I use the NLP endpoints in conjunction with the knowledge graph endpoints to extract things like parts of speech or entities and syntax. And so what it's done is it's helped us identify which tags are celebrities, are nouns, are verbs, are adjectives, and so we can identify emotions, reactions, and those kinds of things. We can use that data now to create like really awesome human readable titles for all our GIFs. And we're integrating that right now and should be shipped relatively soon.
Awesome. So you're using the syntax annotation to extract different parts of speech, and then using the knowledge graph API to get more details on that.
Exactly. Yeah. I mean, it's provided a really awesome way to add hierarchical data to our tagging system. And again, these things that Google provides, they're hard to replicate in-house. And so, we're a startup. We got to move fast. We got to ship product, and we don't really have time to reinvent the wheel.
Definitely. So how have these APIs simplified your development process?
Yeah, like I said, building machine learning models is really difficult. It takes a lot of time, it takes a lot of data, and it takes a lot of specialties. Being able to hit such high quality models like Google offers through their API and get just really powerful data back, especially at scale, it's really transformative. It's a great way to use kind of these amazing things that have been happening in the machine learning computer vision world without having to necessarily have a crazy data science team in-house. So yeah, we've been just hitting those and pulling stuff in. It's been amazing.
Wow, sounds great.
Yeah.
Do you have any advice for other developers that are thinking about using these APIs?
I do. Being a Giphy, I do a lot of engineering work with images, which makes it a lot of fun to build stuff and look at images and look at GIFs. Whenever you get frustrated with code, you can always realize that you're working on a GIF of a cat jumping through a window or something, and take a moment. So I suggest people use the Giphy API to pull images from us and then send those to Google to get more metadata, and then try to find new products or fun things to build out of that. It's a treasure trove.
That sounds like a great integration.
Yeah, I think so.
So if folks want to learn more about Giphy or how you're using Cloud Vision or natural language, do you have any resources that you'd recommend?
Absolutely. We have an engineering blog where we're going to be going in depth to a lot of these integrations and documenting some of the other cool stuff we're working on.
Awesome. Well, thank you so much for joining us
today. Hey, thank you. It's been a real pleasure.
Can't wait to see what's next for Giphy.
It's going to be good.
Another company using Cloud Vision is Box. Box is using the Vision API in their file management system. So whenever you store images in Box, it'll use the Vision API to extract text using OCR and tags using label detection. So when you're looking at images, you can see the extracted text on the left side, along with tags, which it's extracted using label detection. So those are two examples of companies using Cloud Vision in production. The next API I'd like to talk about is Cloud Video Intelligence. With Video Intelligence, you can understand your video's entities at shot, frame, or video level. Let's take a look at the features of the Video Intelligence API. So at its core, it lets you do label detection. Tells you what is this a video of. And label detection comes either at video or scene level. So at a granular level, it gives you data on what's happening in every scene. And you also get higher level video annotations. Another feature of Video Intelligence is shot change detection. So it'll tell you anytime the scene changes in your video. So let's say you pan from a landscape to maybe an interview zooming in on a person. It'll tell you the exact timestamp where the scene changed in your video. It also does explicit content detection, similar to the Vision API, and it also lets you specify where your Video Intelligence API requests should be executed. The best way to understand how the Video API works is through a demo. Let's take a look. So here we have a video of a commercial for Google Photos, and I'm going to play just the first few seconds of the video. So we can see that there's a lot of scene changes happening in this video. And if we wanted to manually write down what was happening in every scene, we need to watch the entire thing and write down what was happening and then save these tags or labels in a database somewhere. The Video API lets us do this with a single REST API request. So what you see below the video here is a visualization of the JSON response we get back from the API. So it tells us what labels it finds, and not only does it tell us the labels, it tells us exactly where in the video these labels occur. So it knows that there's a Pomeranian in the first few seconds, and we have a child here, and then we have a shot of the sea here. So you get the idea. So this is what the Video API can do for one video. But if you're analyzing videos, chances are you have a large video library that you'd like to analyze. So I've got a couple of videos here. And let's say I'm a sports media company, and I've got hours and hours of sports footage, but I want to find all the clips of baseball. So if I were to do this manually, I have to watch all my videos, looking for all those tiny clips that contain baseball in them. With the video API, you can easily search across a large library of videos. So if I go over here and search for baseball in my video library, we can see that it immediately returns all the videos that have baseball in them. So this video is almost entirely about baseball, but I really like this example here because this video only has one tiny 1 or 2 second clip with baseball, and the video API is able to find that for us. So we can jump to it right here, and we can see that this is from last year when the Cubs won the World Series. This is Google's year-end search video, which highlights top searches from throughout the year. So there's many different clips happening in this video. If I were to manually watch it, there's a chance I might miss that baseball clip. So we can see the video API was able to highlight that exact moment for us. So it used to take hours with the video API, now it takes just seconds or minutes. I'll do one more search. It's a little cold out right now, so it might be nice to go to a beach. And while machine learning can't take us there, it can do the next best thing and find us all of our beach videos. So if we search for beach, we can see here that it's identified all of the scenes in our videos that contain a beach, which is pretty cool. So that is a demo showing the Video Intelligence API. So let's take a look at the JSON response for scene level annotations in the Video API. We can see here that we have a clip in our video that contains a bird's eye view scene in it. And the Video API is able to identify this as a bird's eye view. And in that segment object, it's able to identify the start time and end time for this label in our video. It also gives us a confidence score of how confident it is that it was able to correctly identify this as bird's eye view. So we just saw 2 APIs that help us understand visual content, like images and video. Next, we're going to transition into the understanding section and take a look at some APIs that help us make sense of language. We'll start with Cloud Speech. Cloud Speech is an API that lets us perform speech-to-text transcription in over 100 languages. First, at its core, it lets us pass an audio file, and then it returns a text transcription of that file. A new feature that we recently added to the API is speech timestamps. And what this returns is a timestamp for each word in your audio file. This makes it really easy to search within your audio. So if you want to jump to a particular time when a specific word was spoken, you can do that really easily with speech timestamps. It also offers profanity filtering, and it supports batch and streaming transcription. If you want, you can send it a complete audio file. You can also send it a continuous stream of audio, and it'll continue to return transcriptions. The best way to see how the speech API works is through a demo. In this demo, I've extracted the audio from a couple of videos using FFmpeg. Then I sent the audio from all of those videos to Cloud Speech to get the transcription and timestamps. So this demo is going to highlight the timestamp feature specifically. Then I've created a UI to search within the audio for all of these videos. Let's take a look. So this is a video of Oars talking about GCP pricing. And what we see below the video is the Speech API's transcription of the video. And what I've done here is made it so that you can jump to any specific point in the video using speech timestamps. So if I click here, we can see that the video jumps to that exact point. So I have a couple different videos here about different cloud or Firebase products. So let's say I want to search within my video transcripts. I want to search for all my videos that mention Firebase. So I'm going to do that here, and we can see that I get a list of the videos mentioning Firebase in the audio, and I can jump to the specific points where Firebase was mentioned in these videos, which is pretty cool. In the second video, we only have one mention of Firebase, but using the Speech API, we're able to jump right to that point. I want to talk a little bit about how that demo is built. In addition to Cloud Speech, it also used Google Cloud Functions, Cloud Storage, and Google App Engine. In the back end, all of the video files are stored in Google Cloud Storage, and I have two Cloud Functions listening on that Cloud Storage bucket. Cloud Functions let you respond to different events in your cloud environment. So I have one Cloud Function that's triggered. Anytime video is added, it's going to extract the audio from that video using FFmpeg, and it's going to transcode that into a format that the Speech API can recognize. I have a separate function that's generating a thumbnail for my video UI. So once I have the audio extracted, I have a separate Cloud Storage bucket where I'm storing those audio files. And then I have another Cloud Function listening on that bucket to send all those audio files to Cloud Speech. And then they're being stored in a separate Cloud Storage bucket. So the front end doesn't call the Speech API directly. It accesses the videos from one Cloud Storage bucket and their associated transcription JSON from another Cloud Storage bucket. One company that's using Cloud Speech in production is Azar. Azar is a chat application that has connected over 15 billion people so far. They're using Cloud Speech anytime an audio message is sent between people. So whenever an audio message is sent, they use Cloud Speech to transcribe that message. And then for matches that don't speak the same language, they're also using Cloud Translation, which I'm going to talk about next, to translate that message into the other user's host language. One thing you might want to do with text once you've transcribed it is translate it. You likely have users all over the world, and you want to translate it into a language that makes it accessible for them. You can do that easily with Cloud Translation, which lets you translate text into over 100 languages. The features of Cloud Translation are pretty simple. You can either translate text, or you can simply detect the language of inputted text. Here's an example of calling Cloud Translation with Python. You just need to use the Google Cloud Python module, create a translate client, and then pass it the text you'd like to translate. Now notice here that I didn't need to tell it what language the original text is in. It's able to detect that automatically. I just need to tell it the source language which I'd like to translate the text to. Then I can grab the result and print it out. The last API I'm going to talk about today is Cloud Natural Language. Cloud Natural Language lets us understand text with a simple REST API request. Let's take a look at the features of Cloud Natural Language. You can use it to extract entities from text, detect sentiment, so you can see whether a given block of text is positive or negative. You can look closer into the linguistic details of text by analyzing syntax, and you can classify your text content into categories. The first feature I want to show you is analyzing syntax. And to do that, I have this example sentence. The Natural Language API helps us understand text. What I'm going to show you is a visualization of the JSON response we'll get back from the Natural Language API. The first thing it gives us is what we call a dependency parse tree. This tells us how different words in the sentence relate to each other. Then we get the parse label, which tells us the role of each word in the sentence. So for example, helps is the root verb, and API is the nominal subject. We also get the part of speech, so whether each word is a noun, a verb, or an adjective. And we get the lemma, which is the canonical form of the word. So for helps, the lemma is help. And this is really useful if you're counting how many times a specific word occurs in your text. You probably don't want to count helps and help as two separate things. You want to look for the lemma, or the canonical form of that word. And then finally, we get additional morphology details on each word in our sentence. And this is going to be different depending on which language you send to the Natural Language API. The next feature I want to look at is classifying content. So using this feature, you can pass text content to the API, and the content classification method will categorize this text for you into one of over 700 different categories. So in this example, I've taken the headline and the description from a news article, I've sent it to the API, and it's able to identify this as a baseball article with 99% confidence. And what's really cool about this is that it doesn't mention baseball anywhere in the article title or description, but it's able to extract this information for us. And you can see there's different levels of categories. So sports is the top tier category we get, then we get more specific with team sports, and then finally we get baseball. The next feature is entity extraction. And to show you how this works, I have a sentence about J.K. Rowling going along with the Harry Potter theme, and I wanted to see what entities it was able to extract from this sentence. So we got these 5 entities, and let's take a closer look at the JSON response for each of these entities. So notice that the first 3 are all mentions of J.K. Rowling. They're just different ways of referring to her. Robert Galbraith is a pen name she used for a different book series. So the API is able to normalize all of these to point to the same entity. So if we look at the details we get in the JSON response for her entity, we get her name, the type of entity is person, and then we get some additional metadata on this entity. So we get the MID, which is again, same as the Vision API. It's an ID that maps to this entity in Google's knowledge graph. And we get a Wikipedia URL for this entity. For British, the response looks similar. It also maps to the Wikipedia URL for United Kingdom. And for Harry Potter, the entity format looks similar as well. Now, if your entities don't have a Wikipedia page, the entity method will still return an entity for them, but it won't have any metadata associated with it. So if it mentioned my name in this sentence, I would still get an entity returned from the Natural Language API, but metadata would be empty because I don't have a Wikipedia page yet. The next feature of the API is analyzing sentiment. So for this example, the food was terrible, I will not go back. This is a review we might see for a restaurant. And if we worked at this restaurant, we'd probably want to flag this review and we probably want to follow up with this person. But chances are we don't want to read all the reviews we're getting. Maybe we only want to respond to the most positive and most negative reviews. So with the sentiment analysis method, we can extract sentiment details on this piece of text. We get 2 values to help us do that. One is score, which ranges from -1 to 1 and tells us how negative or positive this text is. So for this one, we get -0.8, almost fully negative. And then magnitude tells us, regardless of being positive or negative, how strong is the sentiment in this text. And this is a value that ranges from 0 to infinity. This is normalized based on the length of the text, so we get a pretty small number here, 0.8, since this is just one sentence. The API also lets us do entity-based sentiment. So if we take this restaurant review, I liked the sushi, but the service was terrible. The aggregate sentiment for the whole sentence might not be so useful to us, but what we would want to know is that the person liked the sushi, but they didn't like the service. And the API is able to give us a sentiment value for each entity it finds. So here, for sushi, we get a sentiment score of 0.9, almost fully positive. And for service, we get a sentiment score of -0.9, almost fully negative. So we get some really useful insights here from entity-based sentiment. One industry we've seen these APIs used a lot is in customer service. So one example is, let's say you have a call center. You could use Cloud Speech to transcribe the audio from those calls. Then you might use Cloud Translation, if the calls are in different languages, to translate them all into the employee's host language. And finally, you could use Cloud Natural Language to extract additional insights from those calls. So we've seen in the understanding section, we went through Cloud Speech, Cloud Translation, and Cloud Natural Language. That's all I've got for today. I really encourage you to try out all of these APIs in the browser. If you go to any of the links for each of the APIs, you can upload your own images, video, audio, and text, and see the API response in the browser before you write any code. Then when you're ready to dive into code, you can take a look at the code from the demos in this talk in my personal GitHub repos. And we also have a number of client libraries to call the APIs from your favorite language. Thanks for tuning in.
Awesome. And next, joining us, we have our audiences from the AI track, where they just finished up a crash course on the machine learning APIs that we have at Google Cloud. Did you get a chance to watch that one?
So yeah, so not at this time. So I actually watched this one during the Australia-New Zealand session. So Sarah Robinson did this one. It's a really good introduction to the machine learning APIs. So if you don't have a bunch of data scientists on hand, and you don't have a bunch of PhDs in order to build those models, you can actually use some of the things that we've built for you. So a lot of pre-built solutions that you can just call the API, get the information that you need, and use those just by introducing those tools to your developer team.
That's correct. And what I particularly loved was about the video intelligence API, because that is really something unimaginable. Like if I were to watch a 1-minute video, I would probably be able to remember only about 50 things. But that's what the video intelligence API does. It completely maps out every single thing that you see throughout. So that's amazing. And I think the next session coming up in the AI track would be the reimagining conversational experience with the Cloud Speech and Dialogflow. That's really interesting, Jay. We've seen a lot of use cases and customers for that in India as well. So yeah. I think that should be one session to watch out for.
Yeah, chatbots in Southeast Asia are a very big topic. And if you're familiar with API.ai, it's been rebranded as Dialogflow. So you'll have a really good introduction there to Dialogflow and how it can be used to build those chatbots in a really sort of drag and drop kind of way.
Really interesting. And next, joining us are the Industry Solutions track audiences who've just finished attending a session on accelerating delivery of healthcare solutions with Google Cloud and AI. And the next on that same track is the future of financial services, cloud, and machine learning. So I think this is something really interesting, Jay. What do you say?
Yeah, I think for both healthcare, where they've just come out, and financial services, the most interesting there is both of these are heavily regulated industries. So the ability of those industries to leverage what Google Cloud can bring or what the cloud services can bring is extremely important. And those companies that can figure out how to leverage that the fastest and the best are going to be one step ahead of the competition. And in fact, there's a statistic that essentially 38% or companies across industries can expect an increase in profitability by 38% by introducing AI to their workflows.
Wow, that's some figure. So we'll let you guys go back to the sessions, go back to all the 3 tracks that we mentioned, and we'll see you once you are done.
Great.
Hi everyone, welcome back to Cloud on Air, the journey from big data to AI. I'm Dan Aharon. I'm excited to be here with you guys, and I'm here to talk about human-computer interaction reimagined. We're going to focus sort of the first part of our talk today on conversational AI and dialogue flow, and then the second part of the session is going to be about speech recognition. Throughout the whole session, there are going to be expert Googlers available at your disposal. So if you have any questions, please go through the Q&A and ask whatever's on your mind, and we'll be here to help you. So let's start with conversational AI. So conversational AI is a really exciting space, and we're really just at the beginning of it. So you know, there just a few chosen statistics, but there's way others out there. Analysts say 80% of all customer interactions that happen between businesses and customers today can be automated with chatbots or other conversational agents. So, you know, obviously that's huge. $65 billion of potential salary savings could be created by chatbots, and then, you know, obviously those efforts could be redeployed into other areas that would help those businesses. You know, if you look at the consumer side, they say they don't care as much about cost savings, but consumers will say, you know, 60% of them say that they actually want self-service. They're not always looking to talk to a human agent for every single thing that they want to do, especially if it's something simple and transactional. And then if you look at you know, what enterprises spend, chatbots and conversational AI is going to be bigger than mobile in a few years, which is, you know, obviously already pretty big. So that's quite exciting. There's a diverse set of use cases for conversational AI and chatbots, and we kind of touched a few of them in the previous slide. But the first big set is connecting businesses to their customers, and there you could think about you know, customer service or commerce through conversational channels. The second is controlling IoT devices, for example, operating your TV or operating your car with voice commands. And the third is connecting businesses to their employees, making information more readily available than it was up until now. However, as most of you know, the consensus out there is that most of these conversational agents are not that good. Right? If you search on Google why chatbots, one of the first results is why chatbots fail. If you look on the right-hand side, you can see just one example of you know, a conversation gone bad, and this is pretty typical. There's you know, a lot of excitement and a lot of adoption for chatbots and conversational AI, but a lot of it is really not up to the consumer expectations. The good thing is we think with Dialogflow, we can really address a bunch of these. So Dialogflow is making AI accessible. Dialogflow is built on conversational context. So you could get different answers depending on what users said previously in the conversation. And Dialogflow will allow you to integrate with your existing business systems and your existing systems for human live agents that will let you do escalation. Then for the other three, we're working very closely with customers to sort of help share best practices and help share guidance about how to build great conversational AI experiences, and we'll come back to that a little bit later in the presentation. So, just at a high level about Dialogflow, what it does. So what it does is it takes unstructured text and turns it into structured text. So if you have this sentence where a user is asking for a pizza with different things on it, we turn it into a structure that then you can use in your business applications, like you can see on the bottom. What it doesn't do is, it doesn't really understand your domain until you train it, and it doesn't do any of the fulfillment. Luckily, we provide very easy tools to train, and GCP is a great place to host your fulfillment. So, we're not going to, Dialogflow is not going to create the pizza for you, but GCP will help you connect to your backend systems that can do that. So Dialogflow is one of the most widely adopted conversational solutions out there today, with over 300,000 developers. It's much larger than any other vendor that publishes their numbers, and we're very excited about the very terrific adoption that Dialogflow is seeing. When we hope you guys are going to help us sort of increase that community even further. So when we think about why people are choosing Dialogflow, we talk to developers, and we ask them that question, and so the consistent answer that we get is people choose Dialogflow because it's a higher quality natural language solution, and the accuracy of the results is better. So they, even though all of these different solutions kind of look very similar, when you actually try and run them in production, what you find is, not everyone is able to give you that great end user